Okay, so welcome to week 8 of Learning Analytics Tools course. So this week we have again we are continuing with predictive analytics. So I will start with revision of this week's content, and then we'll move on to last run's assignment solving. Okay, so as now we are done with descriptive analytics, which answers our what question, what our data looks like. Then we also saw a diagnostic analytics, which gives us answer to which actions lead probably to the outcome, whether it is desirable or undesirable outcome. We can analyze what actions or what set of actions are responsible to a certain type of learning outcome achievement. So that we see in diagnostic analytics, and then in predictive analytics we can predict the future, based on the historical data or based on previous data, what next is going to happen, so that we can uh, predict using predictive analytics, prediction of future. Yeah. So in that we are seeing regression now. We saw clustering and other things last week, and this week we are going to predictive analytics and particularly regression. So regression is a statistical model which will help us establish some relationship between dependent and independent variable. So when we are measuring some variable, or when we have data about certain variable, and we want to establish that some another variable has some relationship with this variable, and then we'll try to establish that using a statistical model, using some equations. So that will be part of regression. So based on how many dependent model and how many independent model and what type of relation is among them, there are certain types of regression. Yeah. So there is simple regression or multiple regression, or then there is univariate regression and multivariate regression. So simple regression, as the name suggests, it's very simple: single independent variable and single dependent variable. So there will be just one independent variable, and a single dependent variable will be dependent, or we can have some equation based on the value of independent variable. What is the it has to be independent, not dependent. My bad, involves single dependent and single independent variable is the simple regression. Then there are multiple regression, where there is a single dependent variable and multiple independent variable, where there are multiple values which will help us determining a single dependent value variable. Then there are univariate regression, where there is one independent and one dependent variable. And multivariate regression, where it involves multiple dependent and multiple independent variable. Yeah. So based on number of variables, and based on whether it is what type of variable it is, whether it is categorical variable or continuous variable, we will see how to fit it into different types of regression. Yeah. So one simple regression type is linear regression, which can be very easily established by the simple line equation, not the linear line equation. Y is equal to some slope, like generally what in our school days, this is the equation which we have followed, like m is the slope and x is the x variable, or independent variable value, and y is dependent variable, and c is the constant or the intercept value. Yeah. So if you all remember, in our high school we have done this. We'll plot the numbers, and then we have to see the best fit line, which will be best representing these values. So if you all remember, that was nothing but we were doing linear regression. We were trying to fit a straight line through the points which we plotted, and then this equation of this line would be y is equal to some slope into x variable and the intercept, c value of y intercept. Yeah, so same notation is followed here in this equation, and here the main goal is to find the linear relationship, which straight line is the best fit for the given data. That's the aim. So even if our data distribution through our scatter plot, we can clearly see if it is not linear or some other shape also follows, like log or some other type of relationship like non-linear relationship, but still with the in linear relationship we'll try to determine which line is the best fit. Okay, so the main goal is to investigate only the linear relationships. Then what happens when there is no linear relationship, right? When we see data is not data cannot be kind of fit into a straight line, then their logistic equation, logistic regression comes. Yes, Rija, you have something to ask?
No, ma'am, no, ma'am.
Okay, okay. I thought you unmuted, and we have very few people today, so I thought, yeah. So there are very few people, so please feel free to unmute. We can have a discussion mode pretty much on today, because lesser people and more active discussion we can have among ourselves. So it's very good that there are just 4 5 of us here, so we can have active discussion. So if you want anything to be repeated, or if you're not understanding anything, please let me know then and there itself. Okay, so so we saw that for linear regression there is a line equation which is followed, and for logistic equation something called sigmoid function is followed. So sigmoid function will give us non-linear relationship, something like this, or when the relationship is like this. So all such best fit or error minimizing relationships can be determined using this sigmoid function or logistic regression. Yeah. So that was the revision. Again, the main focus of the question, so many new things will be coming up in the during the questions. So main focus of these questions is for us to understand how this regression works and how to evaluate which regression is best fit for us. Yeah, so don't get scared by these formulas or anything. We just have to understand, because we are not expected to we are not expecting you to be able to do this regression yourself without any computer, because there are many tools available, there are many websites available which will do this regression for us. So what our aim is, so that we understand which is the best regression model working for our data. Okay, so don't get scared, the questions will be very simple, the words will be very hi-fi, but our aim is to understand and interpret those words. Okay, so coming back to the question 1 is, which of the following is used for prediction? So k-means clustering, sequence pattern mining, multivariate regression, and Spearman's correlation. So Spearman's correlation is correlation coefficient. Are we predicting anything here? No, right? So this cannot be the answer. K-means clustering is a simple clustering exercise which will help us in kind of creating profile of different students, or closely grouping the students which have features which are close to other students also. Yeah, so this also we cannot use for prediction. Now I am able to see on somebody answering as option 2. So sequence pattern mining, or SPM, is a diagnostic analytics technique which using which we can analyze our log data for frequent patterns, the sequence of actions which occur very frequently for user. Mining such sequences of actions is called sequence pattern mining, or SPM, and this particular method is diagnostic analytics, and we don't use this for predicting anything. But when we want to understand which actions are leading to which learning outcome, in such cases we use SPM. So our answer is regression or multivariate regression, in which we will be establishing a statistical model. We will be developing a statistical model which will help us establishing relationship between dependent and independent variable. And in multivariate regression, there are multiple independent variable and multiple dependent variable. So now coming to this question. So this is for next 5 questions. This table is showing gate score and GPA of the students, and we are supposed to be using linear regression model to get the best fit line, and this is the equation they have given, right? So what we have to do here is, this is our x variable, yeah, GPA, and gate score is y variable, yeah. So how to determine which is x and sorry, I made mistake. So how to determine which is x and which is y? If you see, we are multiplying by 0.02, so number will be like, we are dividing it by 100, almost 100, right? And then we are adding 1.63 to it to get the um, dependent variable value. So my intuition says that dependent variable or the y value will be somewhere close to 1.63, because for x is equal to 0, y value is 1.63, right? So the intercept value is 1.63. So intercept value has to be closer to the dependent variable value. So as you can see, 1.63 is closer to GPA values, right? GPA values here, 1.63 is very close to that compared to the gate score value, right? So that means x, which is our independent variable, is the gate score.
Ma'am.
Yes.
Ma'am, please. So, first options, first assignment.
This is the assignment.
First option. So, first number question.
Your first question is this. Now, I already did that. SPM is a diagnostic analytics technique, and it will not be used for prediction, or it will not be part of predictive analytics. For K-means clustering is also for diagnostic analytics, when we want to understand which students are together, um, whose features are closely related to each other. And Spearman's correlation is nothing but correlation, or when we have to establish the dependence or independence, the relationship between dependent and independent variable. Yeah, so that time, so this is also, we don't use Spearman's correlation for prediction, so we use only regression for prediction. So multivariate regression is where there are multiple independent variable and multiple dependent variable. So that's why correct answer is option 3.
Okay, ma'am.
Now coming to question 2. So this is how we determined which is independent and which is dependent variable, yeah. So I put the values, x is equal to 0, then I got y value as 1.63. So here the outcome or the dependent variable will be GPA value, and the x value will be the gate score value. Okay, so what we will do is, we will try to put all these values in the equation 1.6 plus 0.02x to get the y value, or the predicted y value, yeah, predicted GPA score. So we will please sit with the calculators and help me do the calculations faster, hopefully. ठीक है. So 0.02 multiplied by x value here is 34 plus 1.63, which is something wrong. 0.02 34 plus 1.63. Yeah, I made some mistake into, yeah, 2.31. Now going to second value, 0.02 multiplied by 36, adding 1.63, we got 2.35. Similarly, changing the value here to 0.02 multiplied by 60, and the answer is 2.83. Then 0.02 multiplied by 3.2, sorry, multiplied by 87 plus 1.63, 3.37. Then multiplied by 72 plus 1.63, 3.07. Changing just one value, 73 is giving me 3.09. Then 0.02, 3.4 plus is giving me 3.15. Then multiplied by 80 plus 1.63, 0.23, and finally changing it to 81 will give me 3.25. Yeah, then 0.02 multiplied by 90 plus 63, 3.43. Is it 3.43 correct answer? Did I make a mistake? Yeah, 3.43. Yeah. So please cross check.
Excuse me.
Yeah, yes ma'am.
Ma'am, how you got that 1.63 plus 0.02x, ma'am?
This equation, it is given. It was part of question. So we are just here with the information which is given to us. We have not yet moved on to question 2. This is what
Okay,
the
ma'am,
information
it's
we
given
have.
in the problem itself, in this
Yes,
problem.
yes.
Suppose if I want to create a model like this, means how I can create, ma'am?
So there are different softwares. One is Orange, other one is Veka. There are other online services also, which are like Big ML by Microsoft, and other websites where you can actually upload your data files, the Excel files, or in whatever format. And there you can actually choose regression model for your data, and computer will do the permutation combination to get to the best fit line, and to have the best possible linear relationship between these variables, where you need to choose the which type of regression you want to establish between these variables. So these softwares will help you do this. So the whole point of, that's what I was telling in the beginning, that the whole point of making you do this exercise is so that you understand how to choose the best fit algorithm for the data. So linear, so right now looking at this, we don't know whether the best relationship between the gate score and the GPA is linear relationship, or the logistic regression or the linear regression will give us the best prediction. That we don't know. How we can understand is when we try to interpret the result. So in result, what happens is, you will be giving root mean square error, or something else, or the coefficient or row value or some other value, right? So looking at those values, you should be able to do the comparative analysis and choose whatever works the best for your data. That's the learning goal for this particular week. Yeah, so this is part of the equation, but in real life what you can do is, we don't care about these equations. What we care is which algorithm gives us minimum error. So how we calculate the error, the difference between actual values and the predicted values. For us, this is the actual values and these are the predicted values which we got, right? So what's the difference between them? That difference has to be minimum for the best suited algorithms. Yeah. So this exercise, this assignment questions will help us in understand these more. Okay. Yeah.
Okay, ma'am, thank you.
Yeah. Yes, Srijaji.
Just now repeat ma'am once again this question.
I have not done anything. I just put in x values in this equation, which equation was given as part of question. I have just put in x values, and whatever y values I got, I have just wrote it here. That's all I have done. I have not done anything apart from calculations till now. Okay, so once we have done this, now we will move on to next question, which is question number 2. Okay. Yeah. Question number 2 is asking us to find the value of y-intercept. Yeah, so this was the equation which was given to us. Yeah, y is equal to 1.63 plus 0.02 multiplied by x. So y-intercept is nothing but whatever value we get when we put x is equal to 0. So we have already done it here, but let me redo it. So x is equal to 0 makes this whole term 0. So this becomes y is equal to 1.63. So y-intercept is 1.63, which is option number 1. Or in the simple terms, our equation is y is equal to wx plus c. So this c is y-intercept and w is slope of the line. Which line? The linear relationship, the linear regression line. Yeah, so you can do either ways and you can determine what is the value of c, or you can substitute x is equal to 0 and whatever value you are getting, that is your y-intercept. In this case it was 1.63. Going to question 3, what will be the sign of correlation coefficient between the gate score and the CGPA? So this was the equation which we have gotten, right? So what is the general intuition? That increasing value of x, if we increase the value of x, what will be the impact on value of y? What will happen to y? Y will increase or decrease? Y will increase. As we increase value of x, as per this equation, y will also increase. So that means this relationship is positive. We have seen this concept when we saw the correlation wala part. Yeah, so when value of independent variable increase, if the value of dependent variable also increases, that means they have positive correlation. And if we are decreasing x value and then y value is also then also y value is increasing, there is inverse relationship between them, and such inverse relationship is denoted by negative correlation. So right now in this case, Anilji, we don't have the scatter plot with us, but what we have is this statistical equation, statistical model, which tells us how variable x and variable y are related. So using this equation, we can say if we increase the value of x, the value of y will also increase. That means they have positive correlation between them. That is how we got option 1 as answer. Yeah. So what happens when we don't have such scatter plot, but instead we have this equation? So moving on to question 4, find the GPA obtained by a student having gate score of 80 as per model. So we have done this calculation. Let's go back and refer to the table which we have populated for 80. Let me change the color. For 80, this was a value we got, 2.32. We have already done this calculation, so we will not be doing it again. So this brings us to the correct answer. Or what we can do is, we can 63 plus 0.02 x. We can substitute x as 80 and come here. So it will give us the same answer, 2.32. Right? Moving on to question 5, find the value of mean squared error. Right? So this mean squared error. So what is error? Error is difference between actual value and the predicted value, right? Difference between actual and predicted value, and we need to square it, and then we need to find the mean, right? N is number of samples, right? So you don't need to mug up the formula, but just break down the word for it. Okay, mean squared error. So error is difference between actual and prediction. So now squared error, we will square it. Now mean squared error, then find the mean of it. Okay, so now we have this actual and predicted value. We have calculated this in the table here, right? We have this actual value, we have this predicted value. So now let us calculate the difference. What is the difference between these two values? Okay, 0.09, 0.17, 0.29, 0.09, 21, sorry, my bad, 21, 0.
Ma'am,
Yes.
ma'am, I want to ask how did you calculate the predicted value of y?
Using this formula, formula is given, it is part of the question. Just substitute the value of x in it and got the value of y. That was 0.25, 0.61, yeah. So this was difference between y minus y dash, right? So this is the error, or y minus y dash. So now we will square this. Yeah. So again, either you don't have to write it every step, you can do it, but I'm just I'm doing it the long way, so that we are not missing or we are not making any mistake here. But what I'm doing is, instead of writing this, I'm just adding the square of every term directly, right? So I will not be putting every term here, I will not be writing every term here, but I will be doing this summation at the end, addition of all these squares. Okay, otherwise we will be losing on to too much time, So I'm using calculator to calculate, and I have this thing that a simple calculator, scientific calculator, is allowed in NPTEL exams. So you can also keep the calculator with you if you are worried how you will do all these things orally then or by hand. 0.19 square plus 0.25 square plus 18 square plus 616 square plus 0.338, yeah. And now we need to, there are total n, our n is equal to 10. So mean squared error will be 0.43 divided by 10, which will be 0.043. 0.043, right? So here you can just add, but I directly did the square and addition using scientific calculator. So this is the answer I got. 0. So it was 4388 divided by 10, which was 0.043, which is option number 4, I think. Yeah. Okay, so this is nothing but difference between actual and predicted value. Then we squared and we added. Now find the mean of the predicted value. Okay, so we have all the predicted values. We need to find the mean of all the predicted values. Okay, so this column is the predicted value column. Yeah, so we need to find mean of all the values in that particular column. Okay, so what I will be doing is I will be adding everything. 2.31 plus 2.35 plus 2.83 plus 3.37 plus 3.07 plus 3.09 3.15 3.23 3.25 and 3.43, which is this summation is 30.08. Yeah, so if I want to calculate mean, what I will do is summation of predicted value was 30.08 and our n is 10, so we will divide it by 10, so it will be 3.008, which can be closest. Now 3.008 is not in the option, but we can round it up to be 3.01. Since it is greater than 5, when we round it up it will become 3.01. Right, so the answer is option 2. Okay, so moving to next question. So next question can have more than one options correct also. So read all the statements and then we will be deciphering the confusing one. So I'll give a hint, there are more than one statements which are correct. Okay, so let's read every option carefully and write in the chat box what you think are correct options. Okay, predictive analytics in education domain is helpful to the owner of the institutions to predict the rank of their institution among group of competing institutes. So we are concerned with learning analytics and not academic analytics. So if you recall our week 1 content, we had distinguished between learning analytics and academic analytics. So what owners of the institutions will be interested in is academic analytics, but right now scope of this course is for learning analytics, right? So this for commercial gains or for increasing the enrollment in the institutions, if the owners are interested in predicting their ranking among their competitive institutions, that will not be part of our learning analytics, that will be part of academic analytics. Hence option 1 will not be the answer, the correct answers, because we are dealing with, for learning analytics, we are dealing with how learning is happening. We are interested in understanding the processes and optimizing the learning for students, teachers and other stakeholders involved. So as soon as you spot the word owners, you understand that this is out of scope for us, but then also we will be reading it completely. So this statement says the owners of institutions want to predict the rank of their institutions among the group of competing institutes. That means they want to do this analysis for commercial gain and they have no intention to understand how learning is happening. That means this particular option is not pointing towards learning analytics, but it is pointing towards academic analytics. Hence option 1 will not be the answer. So going to option 2, to the learning content developers to provide the adaptive content to learners. So when you want to provide adaptive learning or when you want to provide the adaptive content so that the learning environment, the learning experience is optimized for students. So as content developer, if you're using predictive analytics to predict next action, what will be the next action or what will be the result of a student, so that you can tweak the content according to their needs, so that you identify their needs, so that is correct use of predictive analytics, right? So this option is correct, so option 2 is correct. Now coming to option 3, to the instructors to adapt their teaching strategies based on students' performance. So this is also a correct use of predictive analytics. So simple example is, there is a simple observation that students who fail in mid-semester exam will fail in the final exam. So by using this knowledge, a teacher or an instructor can pay extra attention to students who have already failed their mid-semester exam, so that they don't fail in their final exam, right? So this is how they are changing their teaching strategies using their predictive algorithm. Yeah? So this option is also correct use of predictive analytics. So this is also correct, because instructor or the teacher is also very much part of this learning analytics. They are also interested in whether their learning strategies or teaching strategies are being effective, right? So option 3 is also correct. Now coming to option 4, to the learners to provide feedback and suggestions to avoid failure in learning goal. So this was the classroom example, right? This what happens in classroom. But what happens in a computer based learning environment or technology enhanced learning environment? Technology enhanced learning environment, or TELE. Yeah. So in TELE, the learners are given feedbacks and suggestions so that they don't fail and they achieve their learning goal or learning outcome. So in this case, this predictive analytics is also useful, and it's part of student modeling, where what I mean by student modeling is by modeling the students by identifying their needs, where they should be given feedback, or at this point they should be given suggestion that go back to content XYZ and come back to give exam. So such suggestions, or what we called scaffolds or hints, so how to identify where the student is needing those scaffolds or hints, is using the predictive analytics to predict whether student will do well in this particular module or not, depending on how much time they are spending on that content, whether they have practiced the questions enough number of times, and only then they are proceeding to actually taking the exam or the assessment part. If they are not doing so, then we are giving them feedback that okay, you have not spent enough time on this content, you have not practiced enough, so make sure that you have practiced enough, and only then you take the exam or the assessment. So like if such suggestions we can be given only by using the predictive analytics. That what predictive analytics we have used, or what algorithm we have followed, is students are not who are not spending enough time on the content are more likely to fail in the assessment. Yeah. So just like option 3, where instructors or teachers were using such algorithms, predictive algorithms, here actual technology enhanced learning environment will have its own algorithm or its own regression model to predict whether the student will be failing in learning goal or not. And if the student is failing, they will tailor or adapt the content, give the feedback and suggestions accordingly. Yeah. So that's how the correct answers are option 2, 3 and 4. So so only one person gave option 3 as answer. A lot of you are saying 3. There was no confusion for 4. So okay, we did good. So question 8 is, regression is generally used for what? To predict performance of the learners. Is this correct? Yes. Okay, great. Then option 2, to evaluate strength of predictor model developed. Yeah. So we have seen the equation of linear regression is very simple to understand this. So how we will understand the strength of predictor model is, let me remove this, is confusing. I will erase this. And what we did here is we calculated mean squared error. Error is difference between the actual value and the predicted value, right? So that is what we are calculating, that is what we are calling as error. So this regression, can we say that if the error or the mean squared error value is close to 0, our model, the predictor model which we have developed, is very strong or is very accurate? Can we say that? So if we are tasting multiple regression models like linear regression, then logistic regression, and so on. So if we have such regression models, multiple regression models, and we are evaluating these models, which performs better, we can do so by comparing their mean squared error value. So it will tell us which model is stronger or which model is giving us better prediction, right? So possibly yes. So either underfitting or overfitting, but that we will not be discussing the concept of underfitting and overfitting here for now. We will leave these words out of discussion. We'll focus on simple this thing, that our mean squared error MSE values will be helping us in evaluating strength of the model developed, right? So this statement is also correct. Now coming to option 3, to investigate the relationship between dependent and independent variable, yes. And to exclusively perform cause and effect analysis. So again, correlation is not causation. Okay, so this is so when we try to learn any any statistical algorithm or any statistical model, the first thing is taught everywhere is correlation is not causation. Okay, so there is a correlation between the variables. That doesn't mean that independent variable is somehow they are impacting each other, or is causing each other. So for example, there is a very very interesting picture to have that correlation is not causation. There is a parking lot, and cars are parked likewise, and there is a shade here, and that shade is it is dented because of falling off some tree, or the cause is something else, but there is one cat sitting here. So can we say that there is a cat sitting on that dent of the shade, so that cat has caused this dent in the shade? So correlation is not causation. So if you search on Google correlation is not causation, this is probably the one of the memes which will come on your search screen, that first rule of statistics is that correlation is not causation. So exclusively perform cause and effect analysis is absolutely false. Regression does not help us establishing cause and effect relationship between these variable, but it is just correlation, that okay, there is some correlation that where the cat is sitting there is a dent. That's the correlation between. So we can say that where the cat is sitting there is a dent in the shade. Apart from that, we cannot claim that okay, cat has caused that shade to have a dent. So that's the cause and effect analysis. But correlation is that cat is sitting where the dent is, right? So this is absolutely wrong. We are not performing cause and effect analysis in regression. Okay, let me remove this. I want to display my poor drawing skills. Okay, so coming to 9th question, choose the correct options that best describe the different types of regression analysis. So we have seen the regression analysis, that there is linear regression, there is non-linear regression, and there is multiple regression, there is multivariate regression. So multivariate is when there are multiple dependent and independent variable, and likewise simple and multiple regression is where number of dependent variable and number of independent variable are multiple, and so on. So you will have to read this is part of theory, and there is no logic in this. So some theory statements which you have to understand. Okay, so multiple regression analysis has multiple independent variable and multiple dependent variable. So no, it has multiple dependent variable and a single independent variable. That's the multiple regression analysis. So this is not correct. Coming to option 2, the multivariate regression analysis has multiple dependent variable and multiple independent variable. So whenever we say multivariate or univariate, multivariate is multiple dependent and multiple independent, and univariate is single dependent and single independent variable. So multiple regression analysis has one dependent and multiple independent. Yes, there is one dependent variable and multiple independent variable. This is also correct. And multivariate regression analysis has one dependent variable and multiple independent. So this is wrong. This is multiple regression. Yeah, but multivariate is both are multiple. Independent variable are also multiple and dependent variable are also multiple. So correct answers are option 2 and 3. So this question was based on the definition of what is multivariate and what is multiple regression. Okay, so which of the following is and are true about logistic regression? Yeah, so this is also part of some theory. There is no logic in understanding or explaining. It is what it is, some facts about logistic theory, logistic regression. Yeah, so logistic regression is suitable for predicting categorical value. So yes, this is true. I had, like, when we started the session, I had told that linear regression is best suited for continuous variable value, and logistic regression is suited for this I had not told, so I'll be telling it now, that logistic regression is best suited to predict the categorical values, and for continuous values we have to follow the linear regression. Logistic regression uses maximum likelihood as error minimizing method. Yes, this is also correct. And last statement, logistic regression uses least mean squared error as error minimizing method. No, so mean squared error is used as error minimizing method or evaluating parameter for linear regression, not logistic regression. Yeah, logistic regression uses error minimizing method. Maximum likelihood as error minimizing method, and linear regression uses mean squared error. The mean squared error has to be least or close to 0 for linear regression, and likelihood or probability of that particular value has to be maximum. So that will be the error minimizing method for logistic regression. So correct answers are option 1 and 3. Okay, so this week there were simple calculations. The formula was given and we did some simple calculations. There are theory based direct statements, we understood them also. So for this week, my suggestion would be, don't rely on the numericals alone. Try to understand the theory also. Some theory facts are also important that will help you in determining which algorithm to be used for your data. Like we saw, there are continuous variable or there are categorical variable. So depending on what data you have, you should be able to choose the regression algorithm accordingly. So that's why understanding theory for this particular week is also important. And there is not much theory. If you look at the lecture notes shared on the portal, so the PPTs, the lecture PPTs which Ram sir follows, so that also has like very less theory, but this theory is important for this topic apart from the simple calculations. So you will not be you will be given these formulas also in the final exam if such question comes, so you don't have to worry about it. And so this is the basic trick to remember how to calculate mean squared error. We have been following or computing this error for quite a few weeks now. So error is difference between the predicted value and the actual value. So then we are just deciphering this mean squared error, the group of word, as first we will calculate error, then we will do its square of it, and then we find the mean value. So n here is the sample size or the total number of samples or data points, whatever you find easy to remember. Yeah? So in all these sums, I have not done anything new or anything difficult or anything different. I just use this formula to calculate these predicted values. This is the formula which is already given as part of question, as a part of information. Okay, so just substituted x value, gate score value, and computed these y values and put them down in this table, computed the difference and then added the square and then computed the mean of that square value. No, Shrija, I cannot compute this again. I'm just telling you in short what method I followed. I think this should be enough to solve it on your own also. This is how I did it. I am actually showing you step by step. Doing this again will be a lot time consuming because we are doing so many minor calculations here. I told you that it is simple, that how did I come with predicted values is by substituting, by using this formula, substituted the x value to got the y value and then just difference between the actual value and the predicted value. Then I'm just computing the square of these values here and adding it. I did that using calculator, so I have not populated these values. So this is the addition I got, and I divided by 10 because we have 10 data points, or our n sample size is 10. This is how I computed mean squared error. So there is another suggestion that can you help to solve previous week assignment question. 2 questions, I'm not able to get the right answer. So I don't have access to the questions right now. So if you can share the questions, then that would be great. So I hope, Shrija, this is clear that this is how I computed this particular column. Then the difference between these values, actual values and the predicted values, is this column. Then squaring it is giving me this column. Then this is the squared error. Now adding that and then computing the mean. Addition, I have divided it by how many data points we had. So this is how I got mean squared error. Okay. Now coming,
Yes, ma'am.
yeah, ठीक है. So now coming to this doubt, we have following data point using single linkage, nearest neighbor, agglomerative hierarchical clustering. What is the distance between first two cluster? So agglomerative hierarchical clustering is what? Yeah, this has, which has the I think this particular page has some calculation left. Okay, so what agglomerative hierarchical clustering does is it will kind of consider every data point as single individual cluster at first. So we have 1 2 3 4 data points, right? 1, 2 as one data point, 2, 3 as other data point, 5, 6 as other data point, and 8, 8 as one data point. Yeah, so what they are doing is they are using single linkage, nearest neighbor. Single linkage is what? They are combining only 2 at a time, something like that. They are not combining multiple. Okay, so nearest neighbor, they are clubbing it together. What will be the distance between first two clusters that will be merged, right? So which are the nearest points, you think? What is the distance between point 1 2 and 2 3? If you remember, there was distance formula, difference between x coordinate and y coordinate, right? 2 minus 1 1 and 3 minus 2 1. So the difference between these two is 1 1. Difference between these two is 3 2. Difference between these two is 3 3, and difference between these two is 7 6, right? So which has the closest, which points are closest? These two. Let me check the color. these becomes the nearest neighbor, and 3 comma 3, so if you remember x2 comma
Ma'am, are we calculating the distance or
yeah,
distance formula?
distance, but distance
Okay,
formula I'm not computing the square, because if the difference is higher, so 1 comma 1 and 7 comma 6,
So it will be
it's a
two.
common sense
Okay.
that 1 comma 1 is lesser, so I was coming to
Yes,
that
yes.
only, that the actual formula is
Okay.
this.
Yes, yes, got
Yeah.
it, got it. Yes,
Plus
ma'am.
this, so actual formula is this, but we can by looking at the numbers we can make out that this 1 comma 1 is lesser than 7 comma 6, so that means point 1 comma 2 can be nearest neighbor of this 2 comma 3 and not 8 comma 8, right? So we will be not considering this as one cluster. 1 comma 2 we will not be clustering with 8 comma 8, we will be clustering with 2 comma 3. And now since it is single linkage, that these two data points are gone, so between this 3 comma 3 and 3 comma 2, using this formula, the difference x square plus y square, 3 square is 9 plus 3 square is 9, 18, so this distance is 18, and 9 plus 4 is 13, so this 13 is less, so that means these two data points are in one cluster. So if they are in one cluster, the new cluster centroid is mean of these data points, right? So 1 comma 2 and 2 comma 3, we have to calculate the mean, which is, let me so 1 plus 2 divided by 2 and 2 plus 3 divided by 2, which is 1.5 and 2.5 will be this C1, and this will be 6 plus 8 divided by 2, which will be 13, 6.5 and 7. Yeah? This will be cluster 2. Okay, what is the distance between first two clusters that will be merged? So we have to calculate the distance between these two clusters, right? These will be merged together. Oh, I'm sorry, I did extra steps. The question says what is the distance between first two clusters that will be merged. So we found out that this distance was the least, right? 1 comma 1. This is the least distance, so this will be the first cluster to be merged. Yeah, my bad, I did extra steps. I did a lot of extra steps without reading the questions further. What is the distance between first two clusters that will be merged? So the clue lies here in the type of hierarchical clustering we are using. So agglomerative clustering, what it assumes that all the data points, however many, they will be individually considered one cluster. So what we did simply is computed distance between each of the point. The minimum distance is here. Oh, I'm sorry. Minimum distance is here 1 comma 1 between 1 comma 2 to 2 comma 3. So these will be merged first. As of first merging exercise will be done between these 2 points, 1 comma 2 and 2 comma 3. Yeah. So this is the distance here. 1 1. So either it will be 1 square plus 1 square 2, so answer should be 2, but if we are following the other data points, so the answer should be 1.0. What is the correct answer?
1.41 is the right answer, ma'am.
1.41. Gosh, okay.
Yes.
1.41. It's the 1.41 squared. Oh yeah, we squared. This is the square, na? 1 square plus 1 square 2. So we need to get the square root of 2.
Okay.
Yeah, so this is my bad. Yeah, again,
Okay.
sorry for confusion. So 1 comma 1.
It's okay. It's
Yeah,
okay.
the square.
I also
is
did
2.
a lot
Yeah.
of calculation and like you did here,
Mhm.
but I didn't realize that we have to do the first clustering only.
Yeah, first
Okay, ma'am.
clustering.
Thank
So
you.
first
Got it,
clustering
got it.
this 1
Thank
comma 1, and then we are just squaring it and adding, but I forgot to do the square root. So we have to do the
Okay.
square root of 2, which is 1.41. Yeah.
Yes, yes.
So the correct answer is 1.41. Yeah.
Yes, thank you. The other one, I think lot of people have asked the correct answer. I think maybe they will look into that.
Okay, okay.
One more question is there that also it's lengthy calculation. So let me see
Uh,
if they can correct it.
Okay, okay.
I'll just copy it, but I know how to do that. But many people are asking in the Q&A also.
Okay, okay. So if you're sure, then by mistake there would be some error in marking the correct option in the final portal, I think, maybe.
Yes, so we are waiting for the correction.
Hopefully. Yeah.
Yes.
So this was question number what, if you can tell me?
The second one.
Second, okay. So I'm
No,
just
no.
noting
Which
it.
question you are
No,
asking? The one
we
which I had
solved.
asked you
Yeah, yeah,
first.
which we solved. Like this was the answer, na? Square root of 2, where we forgot.
Yeah. So it was question number 9.
9, okay.
Question number 9.
Okay, okay. So for benefit of everyone, I'm just marking it here. I will not be deleting this,
Okay.
so you can
Yes,
come back
yes.
and refer to it. Let me just do this. Yeah. Okay, this
Thank you,
is
ma'am.
okay. Following are the data points. Initial clusters are this. Oh, this I think if you are similar questions we have solved. So if
Yes,
this you
yes.
are sure, then I will not be doing it again.
Yes,
I
yes.
know.
We are waiting for
Yeah.
the confirmation.
Yeah.
Many people are saying that the right answer is the
Okay,
which
okay, yeah.
I
So
have
there,
also marked.
yeah, so there would be some mistake. This I did because this agglomerative hierarchical clustering is something which we had not done. So yeah, so
No,
this I solved.
that was given for self-study.
Right, right. Right.
Thank you, ma'am.
Yeah. Okay, so here in distance calculations, don't make the mistake which I made now. Please go for the square root also. This is the squared distance, and we need to find the square root also. Yeah, let me just put a square root sign over this. Yeah, this is the distance formula, right? So all the mistakes were getting made because we forgot to put the square root on this too. So we got this difference between x coordinate and y coordinate as 1 comma 1. We will square it 1 again, 1 comma 1. We'll adding it, gotten 2, and then square root of that 2 is the correct answer.
Ma'am, please tell me the step-by-step of Hasidic clustering.
There is a lot of echo from your end. Your voice is not clear, Shrija.
Yes, ma'am. Ma'am, please tell me the step process of hierarchical clustering.
No, so what happens in agglomerative clustering is all the data points are considered as individual cluster. So in the question, it was asked what will be the distance between the two data points which will be merged first. The question was, they have given all the points. These are the points 1 comma 2, 2 comma 3, 5 comma 6 and 8 comma 8. These are the 4 data points given, and they say that what is the distance between first 2 clusters that will be merged. Okay, so the catch lies in the agglomerative hierarchical clustering. Agglomerative hierarchical clustering considers all the data points as individual clusters. So in a way, what they are asking is which 2 data points will be merged together, what will be the distance between those 2 data points. Yeah, so what I have done here is I have calculated the difference between x coordinate and y coordinate of 1 comma 2 and 2 comma 3, which came to 1 comma 1. Then difference between x and y coordinate of 2 comma 3 and 5 comma 6, which was 3 comma 3. Then the difference between 5 comma 6 and 8 comma 8, which was 3 comma 2, right? Similarly, difference between 1 comma 2 and 8 comma 8 is 7 comma 6, and difference between 1 comma 2 and 5 comma 6 is 4 comma 4. Yeah, so we got the difference between all the data points. So now, looking at these numbers, we can say that 1 comma 1 is the smallest number, smallest distance, right? But the correct formula of distance is square root of x1 minus x2 the whole square plus y1 minus y2 the whole square, right? But if the numbers are smaller, their squares will also be smaller, and then the square roots will also be smaller. By that logic, I did not compute this, but concluded logically that 1 comma 1 will be the shortest distance. So these points will be merged first into one cluster, right? 1 comma 2 and 2 comma 3. So this is the distance between them, 1 comma 1, that difference between x and y coordinate. So we have gotten this x minus x1 and y minus y1 as 1 comma 1. So in order to find the distance, we will be squaring this, right? So 1 comma 1, so this is x1 minus x2 and y1 minus y2. So we are squaring it. So 1 square plus 1 square, and then we have to find the under root. This is the distance formula. I have mentioned it here. So square root of 2, which is 1.41. So the answer is 1.41.
Okay, ma'am.
Yeah. So I'll just erase this because this will create a lot of confusion. These were the steps which were not required really. And I will write the distance formula here. So any doubts from current week? I will again repeat that please do read the theory for this week. Theory for this week is important from exam point of view also, and from understanding from learning objective of the course point of view as well. The questions are not really, they are very simple, straightforward, so not really difficult. So if you read theory for this week, then this week could be a good scoring, what you can say, the scoring week. Yeah. I hope we have not solved this question before the deadline, or then I will be scolded very badly if that happens.
No, ma'am, it was already announced. We have requested for the solution. It was previous week,
Yeah.
week 7.
Great.
Yes. Every Thursday we get the solution.
Yeah, so tomorrow will be deadline for week 8, right?
Eighth
Week
one,
7.
yes.
Yeah. And this question is from assignment 7 and not assignment 8. Yeah.
No, ma'am. It is clustering based last week.
Yeah, that I understood by the question. Yeah, with the question I understand from which topic that particular question is. So that's why I was, I immediately tried solving it. Yeah. So if there are no more doubts, then we can close this week's session. Okay, so I will be sharing this PDF again with you all. Let me just share the link here for the the folder where I put all the PDFs which are marked, right, which we used in during the sessions. So I'm sharing that link here. You can find all the week's PDFs here. I will be uploading this PDF also as soon as the session gets over, and I will be uploading this recording also on YouTube for everybody else who could not attend today's session. So yeah, there it is. See you all next week. Closing this session now. Okay, yeah, thank you. Good night.